All right, so we've been into trig now. We've been doing finding sides, finding angles of triangles using our sine, cosine, and tangent functions. We're going to be doing the same thing here, except we're going to have real world problems, real life, real world problems, situations that come up in the real world. And you call them word problems or call them whatever you want, but they are real world problems. And these are the type of things you're going to see on your Regents exam come June. So a lot of reading here on the first couple pages. I'm not going to read every word to you, but there are some things I want to highlight here. First thing is angle of elevation. Okay, so angle of elevation, and they give you some examples of what an angle of elevation is and what an angle of elevation is not. Okay, so angle of elevation is pretty simple. It's basically from the ground up, okay, or from, say, like in the first example, a plane down. Okay, so this would be like a negative elevation from the plane down. Okay, here's if you're on the ground, say you're on a little island here, and there's a plane, right? So from the ocean or river up, so right here would be an angle of elevation. Up, looking up at the plane. Also from the plane down, okay, back to that island, this is an angle of elevation right here. What an angle of elevation is not is this right here. So say you have a building and a person on top of a building, it would not be the angle where the person is standing on the building. You'd have to be the angle down here at the car, for example, would be the angle of elevation. And then if, say, the person was standing on the building looking down at the car, okay, the angle of elevation would be right here, same as it would be as if it was in the plane. Notice how this is an angle of elevation. This is not. I'm putting an X right there. That is not the angle of elevation here. It would be right here, okay? And we'll see that as we work through this. The ladder problem. All right, so the leaning ladder or pole is a common trig problem. A ladder leaning up against a wall or something like that, because what that does is it creates a slant, and it creates a triangle where we assume the wall is straight up and down, even though it's, I mean, maybe if they built the building incorrectly, it wasn't straight up and down, but we always assume in our trig problems that the wall is straight up and down, which makes a 90-degree angle here. So when you lean a ladder up against the wall, it creates what with the ground? So you got the ground, and you got the wall, and then you got the ladder, and that creates a right triangle. So that's kind of what's important here. All right, the kite problem. So see, a person's flying a kite, right? The kite straight down to the ground is the height the kite is off the ground. They drew that here, see? So there's the height of the kite off the ground. Here's the distance, the horizontal distance from where the kite is above the ground to the person, and that creates, again, that right angle. And of course, the length of the string, we got to assume that that string is pulled taut. All right, that means it's pulled as far as it can be, and it's straight. That creates a right triangle as well. All right, a guy wire. A guy wire is, ever seen like a baby tree, and so to make sure that the tree grows straight up, okay? Or it could be, pretty much for trees, I guess, big bushes or whatever. But you ever see those wires that are attached to the ground? That's called a guy wire. The guy wire is right there, and the tree we assume is straight, even though we know all trees aren't straight. But we assume when we're measuring the height of the tree, we measure it from the ground straight up. So we do assume that it's straight up and down. There's that right angle there. Then this would be the distance, horizontal distance from the bottom of the tree to where the guy wire hits the ground. Of course, look what's formed, a right angle, so a right triangle, okay? The shadow, right? Where do you see your shadow? You see your shadow on the ground. So whenever they say shadow, whenever they say shadow, it is on the ground. And they label that right here. So shadows are on the ground. Height of the person, straight up. You measure height straight up and down. So the shadow with the person's height makes a right angle, and then the sun's rays is that third side, and that makes a right triangle. All right. How about viewing something? So from a plane, for example, if you're in a plane and you're viewing something, say an island, right? There's that, and then the height of the plane makes a right angle with the ground or the ocean, whatever it is, and you have a right triangle problem. Also, you could have it like this. Horizontal distance, angle of elevation could be up here, and then this is the altitude. You can measure the height this way. So there's lots of different ways to set these problems up, and we're going to practice doing that now. So some examples. All right, so example 1, and that's pretty much all we have here. Well, not pretty much all we have. We have 4 examples, but that's all we're going to do, and we'll be done with this video here. So a 3.4 foot, supposed to say foot, guy wire is attached to a tree 3 feet from the ground. What is the angle that is formed between the wire and the ground? So you got to read carefully. What is the angle formed between the wire and the ground? Between the wire and the ground. There it is. Theta. They already labeled it in the picture. So we're finding this angle. Now what's given? The height of the tree is given to where it's attached. Not the total height of the tree, but to where it's attached, which is all we care about. Here's our right triangle. All right. It's opposite. This is opposite, and this is hypotenuse. Opposite over hypotenuse is sine. So we're going to use our sine function. I should have put that over here. Opposite over hypotenuse. That's how we know we're using sine. Okay, so it's going to be sine theta equals opposite 3 over hypotenuse 3.4. And of course, we do our inverse function, our inverse sine, 3 over 3.4, whatever that is, whatever that comes out to be. And we can put that right in our calculator, and that's going to give us 61.93. And so that's going to be approximately 62 degrees. All right, 62 degrees in to the nearest degree. All right, this one here, 15-foot ladder leans against the wall, 52 degrees. How far from the wall is the foot of the ladder? That's this X right here. They already labeled it for us. All right, so now, based on this angle of 52, it's adjacent and hypotenuse. Adjacent hypotenuse. So I know adjacent over hypotenuse is cos. So we're going to do cosine 52, because I know the angle, equals x over 15. Adjacent over hypotenuse. Put that over 1. And I'm going to cross multiply. X equals 15 times cos 52. And again, that's calculator. I know you don't have a calculator at home with you, but that's okay. You'll trust me. I typed that in. You know how to type that in. We've done this, right? X equals, it's 9 feet. 9 feet. All right, and this one here is a tree. The sun's rays strike the ground at 55 degrees, 21 meters from the base of the tree. What is the height of the tree? All right, so they strike the ground 21 meters from the base of the tree. Where's the height of the tree? Here's our right triangle. All right, and it's from this angle, it's opposite and adjacent. This is adjacent, so we're going to do tangent. Opposite over adjacent, and that's going to be tangent. All right, so it's going to be tan 55. Tan 55 equals opposite, which is x, over adjacent, which is 21. And again, we cross multiply. X equals 21 times the tangent of 55. Of course, you can go to your table and get tangent of 55, or calculator tan 55 times 21, and that's going to give me 30. I did these ahead of time to save us time on the video. You don't want to see me typing in stuff on the screen. I think that would just waste time. All right, last one here. Change colors to separate. This is a person. Little boy flies his kite. String forms an angle of elevation. See how that's at the ground level there? looking up at the kite, 37 degrees, 45 feet from the kite. That's where he's standing. And we're trying to find the length of the kite string. That's this right here. So now it's going to be adjacent over hypotenuse. So that's going to be cosine. Cosine 37 equals adjacent 45 over hypotenuse x. Now this time, when I cross multiply, it's x times cosine 37 equals 45. So I actually have to divide by cosine 37, whatever that is. So that cancels out. So I can get x, divide by cosine 37, and x equals, just going to put it over here because I'm running out of room, 45 divided by the cosine of 37 comes out to be 56 feet. So that string is 56 feet long. Okay? And I will see you tomorrow for some more practice.